Hello, welcome to the world of chemistry. So today we will discuss about the classification of periodic table into blocks. So the periodic table can be classified into four blocks, that is known as S block, P block, D block and F block elements. So first we will discuss about the S block elements. Okay. So here we can see the periodic table. So here we can see, so from table 1 to table from group 1 to group 18 elements are there. Here we can see the non-metals, metals and alkali metals, alkaline metals, then inner transition metals, actinides, lanthanides. So everything is there. Atomic number, atomic mass also given. So we will discuss one by one. Okay. So first one is S block elements. In S block elements, so the differentiating electrons here, the differentiating electrons enters the s orbital. So here the elements enters the s orbital to the valence shell. Okay, s orbital of the valence shell. So their electronic configuration is ns1 to 2. Okay, so here to the S block elements, group 1 and group 2 elements belongs to S block elements. So group 1 elements are called alkali metals, group 2 elements are called alkaline earth metals. Okay, then we have P block elements. Here the differentiating electron enters the p orbital of the valence shell, from p orbital of valence shell. Okay, so the general electronic configuration is ns1 to np1 to 6. Okay, so elements of group 13 to group 13 to 18 belongs to this group. Okay, this block. Then the elements of group 18 are least reactive. The elements of the group 18 are least reactive. Which are the 18 group elements here? So 18 group elements are the noble gases. So they are helium, neon, argon, krypton, xenon and radon. Okay, and why they are least reactive? Because of their stable electronic configuration. So the noble gases have stable electronic configuration, so that's why they are least reactive. Okay, so they are called as noble gases or rare gases. So the next one is D block elements. In this block, the electron enters the penultimate shell. Okay, before it used to enter the valence shell, here it is entering penultimate shell. Okay, the general electronic configuration is, here it is given n-1. Okay, n-1 d 1 to 10 ns 1 to 2. Okay, so the elements present in the group, here the elements present in the group 3 to 12 belongs to this group. Okay, for the S block it is group 1 and group 2 elements, they are alkali and alkaline earth metals. For in the P block elements, from group 13 to 18 belongs to P block elements. In the D block elements, group 13 to 12 belongs to this block. Okay, these elements are called transition elements. Okay, these elements are called transition elements. So they are all metals. Here in the transition metals are all metals which exhibit, okay, metals which exhibit properties like variable oxidation state, that is variable oxidation state. So they are not stable, they are variable oxidation state, okay, OS. Then formation of complexes, formation of complexes also the variable, formation of complexes. Okay, next moving on to the F block elements. So in this block the differentiating electron enters the here the differentiating electron enters the anti-penultimate shell, anti-penultimate shell, okay, anti-penultimate shell. Okay, the electronic configuration is here, it is given n minus 1 f 1 to 14 n minus 1 d 0 to 1 n s 2. Okay, so this block includes this block also includes lanthanides and actinides, lanthanides and actinides. Okay, so the elements from cerium to lutetium and constitute a lanthanide series, okay, that is from atomic number 58 to atomic number 71, okay, these are called lanthanide series. Similarly, the elements from thorium, the elements from thorium to larvencium, okay, larvencium, that is from the atomic number 90 to 103 are called actinides or actinide series. So the whole together are called inner transition elements, they are called as inner transition elements. So the important thing is here is 4F and 5F block elements are also known as rare earths. So as they generally occur in the earth crust to a small extent, okay, to the small extent. So next some of the merits we have, merits of long form of the periodic table, long form of periodic table. So modern periodic table provides an easy way to remember the position of elements and predict their properties, okay. So the first merit is modern periodic table provides an easy way to remember the position of elements and predict their properties. And the second one is it is based on the atomic number, it is based on atomic number as well as the electronic configuration, atomic number also and electronic configuration. Hence the group number of elements is actually the number of electrons in the outermost shell around the nucleus, okay. The third merit is several defects found in Mendel's periodic table, but that have been rectified in the long form of the periodic table, okay. Next the fourth merit is Nobel gases are placed in the extreme right, that is group 18, okay. Extreme right means that is group 18, indicating the completion of S block and P block elements. So here they indicate that the P block and S block completes over the to the 18 groups, okay. Then the fifth merit is the periodic table clearly divides the elements into S, P, D and F, means it gives exact idea of the elements and it is easy to understand how elements react on their on their properties, we can classify them as metals, non-metals, okay, alkali metals, alkaline earth metals. So this is the exactly the merit only. Okay, now we'll see some demerits of the long form periodic table. Demerits. What are demerits here? So the demerits is, first one, position of hydrogen is uncertain as found in the Mendeleev periodic table. In the Mendeleev periodic table also the hydrogen position was uncertain. So why? Due to the similarities. So the hydrogen can also be placed. Hydrogen can also placed in group 1, or group 17 or group 14 of the periodic table. So hydrogen can also be placed in group 1, group 17 or group 18, but why it is in the group 1? So that is the demerit. Okay, then the second demerit is F block elements. The second demerit is F block elements are not placed in the main periodic table. They are not placed in main periodic table. They are written separately. At the bottom of the table. So that means they are actinides and lanthanides are written in the bottom of the periodic table. That is the demerit of it. So they can't explain why the position of hydrogen is in the first element in the group first, whereas it can also be placed in the group 17 or group 14. And the second demerit is, so why the actinide series and lanthanide series is bottom of the periodic table. So this is all about the classification and merits and demerits of the periodic blocks. Thank you. So for the more interesting videos, please subscribe, share and like the video.